This video is just about differentiating polynomials. What does that mean? If you don't know what it means, then probably this is the right video for you, because it probably means you're just starting out with differentiation, and the first thing that all my students I've ever seen learn is this. There's loads of advanced ways of differentiating. We're not doing that this time. You might have already been looking at the screen. So this first screen, I'm just looking at 5 different ways to ask the question differentiate. So let's answer this first one here. Well, the answer to that is dy dx equals 3x squared, because that number drops by 1 and then the original number goes in front. What about the other 4 questions? They're all asking exactly the same thing, but just in different ways. Equals, I'm going to put an arrow there. I'm not really sure what else to write. Slightly strangely worded question, but it would normally part of a longer question, I think. Well, I could write gradient equals 3x squared, because when you differentiate, you're finding the gradient. Now, y dash is a shorthand way of writing dy dx. And I use it a lot personally because I'm lazy and I like to be able to do less writing and save time. Now let's do a whole bunch of example questions. I think there's 8. Pause the video each time, have a go in your own time. These are kind of slightly difficult questions, I think. Well, I'm going to use my indices knowledge, because I know that y equals x to the half, which means that dy dx will equal half, a half x to the minus a half, because I have to take one away. Let's do the next one. Well, that's the same as x cubed, because we've got to simplify it first. We can only differentiate something if it's just like a single thing to a power, so that'll be 3x squared. Again, remember to keep pausing the video if you want to try these on your own. Okay, I can't combine these, so we've got 2 separate things, but fortunately the way differentiation works is we can actually just do this. That's 2x to the 1, but obviously I don't have to write the 1. Let's just go back to that previous question, by the way. So, because there was a plus, we can treat it as 2 separate things to differentiate each one separately. It's very rare, almost the only time that we can do something that isn't x to a power. Okay, what about this? Well, that'd just be 7.1 x to the 6.1. That's not x to the power, is it? Which means we're going to have to change it. So let's multiply it out. I'm just going to save time and write the answer down straight away. If I multiply out those brackets, that's what I get, which means dy dx will be 2x plus 2, and then the plus 1 just differentiates to nothing. Why is that? Because that's just like a graph of y equals 1, and the gradient of that is 0. Let's do the next question. What's dy dx? 0. Because as we said just on the previous question, let's just do it again. This is the line y equals 5. What's the gradient? Oh look, the gradient of that line is 0 because it's horizontal. What about this one? Well, the 5 over 3 goes to the front, and then we just minus 1 from that. So you could do it separately, and you could maybe change that to 3 over 3 just to make the maths easier. Oh, that's 2/3, so we stick 2/3 there. And what I was trying to model was, if you got fractions and stuff, maybe separate it out, do the working separately, and then write your final answer. Because I see a lot of students make mistakes with things like this because they just go a bit too fast because they're in differentiation mode and forget to just go into fraction mode. Last question, have a go at this in your own time. Well, this is a power, that's x to the minus a third, which means dy dx, the minus a third goes in the front, and then I'll do a bit of working up here just to be sure that I got the fraction correct, and that's minus 4 over 3. There we go. Thanks for watching. Hopefully that was helpful.